You may have seen many videos about quantum computers on the internet, but if you have been following the news recently, there's something exciting for you. Microsoft has unveiled a quantum chip that has the potential to change everything. This processor is called Majorana-1, and it could solve problems that even today's supercomputers cannot handle. If Microsoft can upscale this processor by increasing the number of qubits, then the futuristic ideas we discuss about quantum computing could become a reality in just a few years. But let's try to understand exactly what Microsoft has announced. Microsoft has introduced a fascinating device called Majorana-1. Some are even calling it the world's first quantum chip, which features a topological core architecture. Unlike traditional chips that use semiconductors, this processor utilizes topoconductors, a term you might not have heard before or only a few times. Topoconductors create an exotic quasi-material known as the Majorana-0 mode. Previously, Majorana particles existed only in theoretical physics, but Microsoft has managed to create them in reality. By combining a semiconductor, indium arsenide, with a superconductor, aluminum, cooling it down to absolute zero, and applying a magnetic field, Microsoft successfully developed this material. The resulting particle is crucial for quantum computing. What makes it special and how does it work? For decades, computers have relied on semiconductors, but this is no ordinary computer. Instead of working on semiconductor technology, it is based on topoconductors. If you're feeling confused, let me explain in simple terms. In traditional computers, data is stored using a combination of zeros and ones. Every processing unit, from the processor to RAM to cache memory, operates based on this binary system, either 0, off, or 1, on. However, in quantum computers, instead of just 0 or 1, we have qubits. A qubit can exist as both 0 and 1 simultaneously, enabling it to perform multiple calculations at the same time. This makes qubits fundamentally different from traditional bits, which are always in a fixed state. With qubits, a quantum computer can process multiple tasks simultaneously. To give you a comparison, even if all the world's supercomputers worked together, they wouldn't be able to perform some tasks that a quantum computer could solve instantly. However, the Microsoft chip I'm discussing isn't that powerful yet. That's why I mentioned earlier that Microsoft needs to scale up this technology to make it a reality. More powerful chips must be developed. If you're thinking about using this processor for gaming or in your personal computer or laptop, that's entirely incorrect. Quantum computers are designed for a completely different purpose. Their primary objective is to solve complex problems, such as scientific discoveries and medical advancements. For example, imagine a disease for which no cure has been found, or a new virus like COVID-19 emerging suddenly without any available vaccine. In such cases, quantum computers could rapidly help researchers discover treatments or develop vaccines. The future of quantum computing. Microsoft's chip currently operates on an 8/8 qubit combination, but they are aiming to build a quantum computer with millions of qubits. Imagine the possibilities such a powerful quantum computer could unlock. With it, we could predict climate patterns in extreme detail for every village, district, and city worldwide. It might even be possible to accurately forecast future weather changes. Currently, supercomputers handle such calculations, but they take significant time. A quantum computer, on the other hand, could process them within minutes. Another example is nanotechnology. You may have heard of nanotech before, or if you've watched the Avengers movies, you might remember Iron Man's nanotech suit, which could repair itself after being damaged. Although that was just a fictional scene, real nanotechnology can be developed using quantum computing. With this, we wouldn't just create self-healing materials, but nanobots that could enter the human body and repair damaged cells. What about software? The next question is, what kind of software will run on these computers? We can imagine any type of software, but the real challenge has always been hardware. No matter how advanced the software is, it's useless without capable hardware. For example, AI-generated images require extremely powerful computers. If your computer isn't powerful enough, you have to use cloud services to perform these tasks. This means you may have AI software, but you lack the necessary hardware to run it. Now, imagine if quantum computers become mainstream and AI starts using quantum computing power, the possibilities would be limitless. The future is arriving faster than we expected. Think about it. Just 5 years ago, if someone told you that you could write a text prompt, and a computer would generate an HD quality image or even a video from that text, people would have laughed. But today, that's a reality. So, with the introduction of quantum computing, what unimaginable advancements await us in the near future? The world is changing faster than we can even predict.